You may have seen lot of communication system block diagrams as a student and as a working professional. One key fundamental terminology that is used in communication system design and analysis is dB or decibel. First, a little history about it. As you may have guessed it, dB is a tribute to Alexander Graham Bell and hence the term Bell is used. So Bell is the unit and what does it represent? It is a ratio of two numbers and in logarithmic representation it can be written as follows. Why do we need a way to represent a ratio? Because in many fields of engineering, for example like in communication systems, be it radar, mobile or antennas, or even in audio communication or video communication, ratio of two quantities plays a bigger role. A very good example is SNR or signal to noise ratio. But remember, when I say ratio, the difference here is that it is a ratio of two quantities with same units. This means the numerator and denominator should have two values which have same units. Example, it can be a ratio of voltages or it can be a ratio of powers and so on. While bell was originally used, but over time, working unit that became popular is decibel. So decibel means 1/10. So to compensate for that, introduce 10 as a multiplication factor in the logarithmic equation. Note how dB is written with D as small letter and B as capital letter. Let us look at an example. Example with ratio of two power levels like 1 watt and 10 watts. So if we take dB or decibels of this, the value is minus 10 dB. Since both numerator and denominator is watts, it will cancel and the value is just minus 10 dB. Now if you swap the numerator and denominator here, so the value is plus 10 dB. While we understood the importance of taking ratio, we should think why dB or why even the log scale. So think of a linear equation with many variables. There are a lot of numbers to be multiplied and divided which is common in communication system analysis. So consider this picture here. Let us say we have multiple blocks in a transmitter system which has gains G1 and G2 and losses L1 and L2 and so on. So now the total gain is obtained by multiplying all these G and L values. But what if you take logarithm of these values? So it will look like this and it will be a decibel format. Similarly, if the equation has terms to be multiplied and divided, again a very common scenario in communication system, it will look something like this in decibels. So you have x1 and x2 which are multiplication and then it is also divided by x3 and x4. We know that these are the common log equations. Log of two numbers which are multiplied is equivalent to addition and log of two numbers which are divided is equal to a subtraction. So basically using these relationships you can convert any of these complex equations into simple additions and subtractions. And with this you don't even need a calculator. You can just add and subtract the numbers. Now let us look at another advantage which is managing a wide range of numbers to a manageable range. Again, this is very common scenario in communication systems. It is very common to see that in a communication system, the transmitter power, for example, could be like 1 watts, while the received power is very low, like 1 picowatt. Handling it and trying to draw it on a graph is something like this. So you have 1 watt somewhere here on top of the graph and 1 picowatt is at the bottom somewhere at very low, and drawing a scale for this is very difficult on the y-axis. Now what happens when we take dB? Now if you take dB of 1 watts, it is 0 dB watt, and if you take dB of 1 picowatt, it is minus 120 dB. So you can see that these numbers which were very wide range are now in a manageable range and you can easily add and subtract these numbers. In the next video, we will learn some more interesting points about decibels.
Please click on like and subscribe to our channel and click on the bell icon for regular updates.